Hello everyone, welcome to the part 9 session of R programming. In today's session, we will see how to install any R package in RStudio. We will install Dplyr package and see the built-in functions of the Dplyr package. We will also see the functions like mutate, select, filter, summarize, arrange and group by. So first let's start with today's session with the R packages and its library path. So R package are the collection of R functions, compiled code and sample data. They are stored under a directory called as library in the R environment. By default, R install is a set of packages during the installation. Now, how to get the library package location where all the packages are installed? So .lib paths will give me the information of the package location where all the packages are installed. So this is I have a MacBook, and on my MacBook under the library directory all the packages will be installed. So if you have a Windows machine, you will see the packages will be installed under C program files r/r the 3. Something latest version /library. Moving forward, library function will give me all the information related to the packages that are installed in RStudio. So when I use library function, I will get the information of all the available packages that are presently installed in my RStudio environment on this MacBook. Moving forward, we will see the command how to install the R packages. To install new packages, there are two ways. One is installing from the CRAN directory and the other is downloading the package to the local system and installing it manually. So we will see how to install it from RStudio, and this machine is connected to the internet, so we will use install.packages and I will give the package name into the quotes. The package that we are going to install is the Dplyr package. So once I execute this command, it will start installing the package. It will take some time. It will say, do you want to install? I will say yes. It will start installing all the packages and its dependency packages. So Dplyr has quite a few dependencies. So you will see all this information regarding which packages have been installed. These are all the dependency packages for the Dplyr package. So once all the packages are installed, we will get the message that the load source packages are installed and under this location. So you will get the message done Dplyr package name. Now once the package is installed, we need to load that package into this R environment. To load the package into the R environment, we will use library and the package name. So after the installation of the Dplyr package, I want to load that package so that I can use all its functions in this RStudio environment. To use that, I will use library and the package name. So this will give me a message attaching the package Dplyr, and we can use some functions like filter, lag, intersect, setDiff. These are the different package functions under Dplyr. Now using the command, we saw how to install Dplyr package. There is another easy method to install the packages, which is at the right hand side bottom corner you will find packages, and in that you will click on install. In that install, you can just mention the package name. It will give you the list of all the packages that starts with D, any package name. So let's see, we want to install Dplyr. I will type in Dplyr, and this will be the install from is the CRAN repository where all the packages are globally located in this CRAN repository. The package name is what I'm using is Dplyr. Installed library is the location where all these packages will be installed. The next option is install its dependencies. This means that because there will be multiple dependencies of each and every package, so do you want to install the dependency packages or not? It's always recommended that you should install the dependency packages. So select this option and then click on install. I will not install now because we have already installed Dplyr package, but I wanted to show you how to install the packages. So there are two methods using the install.packages method, and the second one is to going into the packages and click on install. So this way we can install the packages in the RStudio environment. Now moving forward, we will see what is a Dplyr package and how to utilize that Dplyr built-in functions in the data analysis. So we will learn what are the Dplyr package functions like select, filter, what is pipe operator, what is mutate, arrange, group by, summarize. We have a dataset called as Titanic. We will use that Titanic dataset. It is in form of a CSV file. We will read that CSV file, creating an object called as data. Now we will see str data is the structure of that dataset. So this is the structure. These are the columns, which is PID, P class, survived, sex, age, etc. And these are the different observations. There are 1309 observations with 9 variables. 9 variables is 9 columns that we have. Now let's do head of that particular object. So using the head, we will get the first 6 rows and its information. So now we need to use a select function to do a random on n rows. Now we'll see what is a select function. Select is a function that reduces data frame size to only desired variables for current task. When working with a sizable data frame, often we desire to only access specific variables. Select function will allow you to select or rename some variables. Now let's start with selecting random n rows. So I am using a function sample underscore n that will give me the random rows on the data object, and I want to get 5 rows, 5 observations from this data object, and I will save the result in data underscore sample. So once I execute this sample underscore n function, it will give me any random 5 rows. So you can see the PIDs. That means that these are not in sequence, these are randomly picked. So this is how we get 5 random rows or any number of rows using sample underscore n function. So now we got to know how to get 5 rows or any number. We'll find out how to get 20% of any rows from the dataset. So we will use frac sample underscore frac, which is a fraction, and we have to specify the percentage. So over here, data comma percentage is 0.2 means 20% of the rows from data object, and I'm saving that into object called as data underscore percentage. So these are some 20% rows that we got using that command sample underscore frac. So this is how we can get n number of percentage, n number of rows from any data set. So these are sample underscore n and sample underscore frac. Moving forward, we will use the select function. So select function is used to select, this is the basic syntax, select the dataset name or the object under which the dataset is stored and the column names. So we can select whichever columns that we want from that particular data object. So over here, I'm using a select function. I'm assigning data, that this is the object where my Titanic dataset is stored, and I want these 3 columns, P class, survived and age, and I will pass it that to T underscore data. So once I print head for T data, I will get these 3 columns, P class, survived and age, which we got from the select function. Now select function, we can use select function in different ways. Say example, we want to drop some columns from this particular data set. So if we want to drop any column, we just use a minus sign with that column name, and whichever column that you want to drop, you can add it using a comma separated. So select the data object and whichever column that you want to add. Say I want to remove PID, I want to remove age and embark. So let's see how it works. Okay, from the data set we had P class, survived, sex, SIPS, PSH, parch and fair. We removed PID, age and embark. So if I see the data set, this is the complete data set which has all these different columns: P class, survived, sex, age, but we removed PID, age and embark. So the output that we got over here is just the P class, survived, sex, SIPS, PSH, park and fair. Now you can use the select function using a range. Range means we can give the columns from n to. So let's see, this is the complete data set: PID, P class, survived, sex, age and so on. So I want all the columns starting from P class till age. So the output of this command is select data P class starting from column P class to column age, and I'm printing the head. So we will get P class, survived, sex and age. So this is how we can select the columns, specifying the range of the columns. We can also do the select function using specific keywords like starts with. Say I want to select all the columns that start with P. So I'll use select data start underscore with is my keyword, and in that I will give whichever is the character that starts with. So over here, any column that starts with P. So we have the column that starts with P is PID, P class and parch. Similarly, we can also use the functions such as ends with. This will give me select the columns that ends with a character. We can give any character string. Also contains with any column that contains with the given string that we specify. We can use this contains. Anything that is matches, select the columns that match a regular expression. For example, my regular expression is age, so it will search for the column names and it will match if we have the column called as age. It selects one of the column names that are from a group of names. So example, we specify some group of names and we search that if one of the columns that are present in that string, it will give us that output. So these are different handy commands that are normally used for data analysis under Dplyr select verb. Now moving forward, we will see what is filter. This is the basic syntax: filter, then the data set and the condition. So over here we will apply the condition on rows. In select we apply the condition on columns, but in filter we will apply the condition on rows. So filter reduces rows or observations with matching condition. That means we are applying the condition on rows. Filtering data is a common task to identify or select observations in which a particular variable matches a specific value or condition. The filter function provides this capability. Let's see, I want to filter the data to get all the survived data. So this is my data set. I'll use a filter function and this is one of the columns, and on that column, if that column has 1 in its rows, it will print all information. So this script will give me all the information related to the survived persons in that data set. So I'm just printing the head of this T data. So in that you will see under survived, it will give me the information, all the survived persons that are there in this particular data set. It will not give me survived equal to 0 because I've applied the condition survived equal to 1. Moving forward, we will use p class equal to first, that is the passenger class is the first class and survive equal to 1. So this way we can add two conditions in the filter function. So this is my data. I will use p class equal to first class and survived equal to 1. So I want all the information from the first class cabin passengers and all those who are survived in that first class cabin. So this will give me all the information of the passengers from the first class and who all are survived in that particular data set. Moving forward, we can do similar things which on multiple columns, and we can give it less than greater than sign. So we'll use the same command, which is p class equal to first class and survived equal to 1, and over here we are adding another condition where age is less than equal to 5. So let's see what we get. So over here in this data set, there is only one person, or that one child, which is a male child who is from first class, who was survived, and his age was 4. So this is how we can use filters and perform some conditions. Now let's see how to filter, use the filter function in more deep. So I'm using filter embarked. The condition I'm using is in condition in Southampton and Queenston. So this will give me the information about the people who embarked at Southampton and Queenston. And sample the data 10 replace equal to 2. So I will get the random 10 rows from this particular data, because if I execute it, it will be a huge list, because people who embarked from Southampton and Queenston are huge in number. So I want to just get the sample 10 record. So I'm using sample underscore n, which will give me 10 random rows. And when I print that, I'm getting few information, the sample 10 rows from the people who have embarked at Southampton and Queenstown. Now moving forward, we will see what is pipe operator. So the pipe operator, this is a pipe operator which is a % sign greater than % sign. This is called as a pipe operator, or also known as chaining in R programming. So this Dplyr imports this operator from another package, which is magrtr. This operator allows you to pipe the output from one function and input to another. Example, like it will be whatever we execute from this, that output will be handled to the next command or the next line of that function. So it is just like a chaining. One's output is an input to the second function. Instead of nesting functions reading from inside and outside, the idea of piping is to read the functions from left to right. So we read the functions from left to right. So we have a data, t data, which is an object that I'm creating. I'm using a select function. I'm passing that on p class and age, and I want to get the head of the t data. So this is how we use pipe function. So we will get p class column and the age column from t data. T data is the data set that I have. If you see, this is the t data set. These are the data frame that is stored in t data object. So in that, I'm just selecting p class and age. So it will give me only the p class and head, and I'm doing the head of that t data. So similarly, we can write the same function without piping, without using pipe operator. Like that is t data. I'm using a select function. Data is the main data set that I have, and p class, survived, and age. If I run this, it will also give me the information whichever columns that I've selected in the select function. So you can use the pipe function with or you can write the basic commands like what we did just now using the select function. But normally it's recommended that we should use pipe operator if we are writing the nested functions. Example over here, the nested operations that we write is the empty cars. On empty cars, I am doing a filter where car greater than 1. Now this output will be given to this cylinder. We will do a group by on cylinder. This output will be stored. Again, we will do a summarize. That is another function of Dplyr, group by, filter, summarize. These are different functions. So to use different functions, we are using a pipe operator. So this is where pipe operator comes handy when we have the nested functions that we are using. Similarly, we will move forward and check what is mutate. So mutate is a function that defines and inserts new variable into a table. You can refer to existing variables by name. Mutate function exists to compute transformation of variables in a dataset. Often you want to create new variables that are derived from existing variables. We use a mutate function to clean interface for that doing. Example, I want to create a new column. That column will be some calculation that was from present columns in that dataset. Say over here, we will create a new column like kilometer per liter. This will be my new column. This is under mutate function, and I'm assuming that 1 mpg is equal to 0.24 kilometers. So this is just an assumption. So I'm using a empty cars dataset. I'm using a pipe operator. In that, I will use select. First, I'm just creating the naming conventions where mg is equal to miles per gallon, and I'm just using a renaming of that column names, and horsepower is equal to HP. So this will be just a rename. So we can use select function to rename the columns that we have in the present dataset, and that table row names to columns variable equal to model. So this will give me the output like this. It will have the column names as miles per gallon and horsepower. It was first HP and miles per gallon was mpg. So this is how first I rename the columns. Now once I have renamed the columns, I will see what is the kilometer per liter average for this particular car that we have. So for it will give me a kilometers per liter average for all the cars that we have under model. So we will create a new column. That new column name will be kilometer per liter. So I will use a mutate function. In mutate function, this will be the column name. The first thing that we have is the new column that we are going to create. Now the assumption is 0.425 multiplied by miles per gallon is the kilometer per liter, and I'm applying that on empty cars. So this is how we get miles per gallon, horsepower, and the kilometer per liter. So we didn't have this column, we created this, and this is the calculative column where we multiplied 21.0 multiplied by 0.245, that we got 8.295. Similarly, this is the kilometer per liter for each and every model that we have in this particular dataset. So this is how we create a new column to do some calculations in Dplyr function. Now let's see how we can use arrange. So arrange function is used to reorder the rows of data frame. So any row you can use arrange for ordering the data set, the rows that are there in that data frame. So reordering rows of a data frame is normally a pain to do in R. So we use Dplyr function, which simplifies the process easily. So I'm using an arrange function. This is the dataset name, and I'm arranging everything using mpg. So if you look over here, we have miles per gallon, which is similar to mpg. So once I arrange it, it will be arranged in an ascending order. Normally, if we just use the empty cars dataset, you will see the rows are randomly arranged. It is not in a sorted way. So we will use arrange function to sort that in ascending order. By default, ascending is true. That means the sorting will be done in ascending order. So we want a sorting, we will select one of the columns and we will apply sort on that particular column. So over here, this is the data set, and I'm applying mpg, and I'm applying arrange on the mpg column. So I will get the mpg column in an ascending order. So you can see 21 going forward to 33. This is sorted in ascending order. Now how to arrange everything in a descending order on the same column? So we will use DESC, descending function, on the mpg column and using the arrange function. So you can see over here the mpg column is now arranged in a descending order. So it will have, the first one will have the higher mpg, and moving downwards it will be in a descending order. So this is how we use arrange function. So let's move ahead and check what is a group by. So group by, the major strength of Dplyr function is the ability to group the data by a variable or variables and then operate on the data by group by function. So this will the most data operations are done on the group bys, on the groups defined by the variable. Group by takes an existing table and converts it into a group table where operations are performed by group by. So this is my empty cars. I'm using a pipe operator. I'm using a group by function on cylinder. So it will group all the information. So this is how it will look like. This is the just basic group by of the, I've applied group by on the cylinder function. Now let's see how we check we can apply a proper group by using summarize function. So I'm just creating an object. I'm using a summarize where displacement is done by mean. So we can use a mean, displacement, and HP is equal to mean of HP. So we want the mean of displacement and we want the mean of HP, horsepower, and I'm summarizing it using a summarize function. So this is how we can use a grouping of all this cylinder, HP, and displacement. So cylinder has, there are like 4, 6, and 8. These are the different types of cylinders that are present in the empty cars dataset. So we are doing a mean of displacement, we are doing a mean of HP. So this is the mean, and we have applied group by on this particular cylinders. This is how we use group by. Similarly, we will use summarize. Summarize function creates a new data frame. It will have one or more rows of each combination of grouping variables. If there are no grouping variables, the output will have a single row summarizing all operations in the input. So it contains one column of each grouping variable and one column for each of the summary statistics that you have specified. So summarize is like I'm using a summarize function on the my cars. This is the object of the empty cars dataset. mpg underscore mean is the name of the new object, new column that I'm creating, and applying mean function on mpg. Similarly, kilometers underscore mean, I'm applying, this is a new column that I'm creating, and applying mean function on kilometer per liter. So this is how we will use a summarize function. That summarize function in this script, we are creating, we want a column that is mpg underscore mean, and applying a mean function to miles per gallon and applying mean function to kilometers per gallon. So over here I'm getting a calculative field which is miles per gallon which is a mean of miles per gallon, and which is a mean of kilometers per liter. So this is how we use summarize. Now we will see how we can use group by with summarize. So this is my empty car dataset and applying group by on cylinder. Similarly, after that I'm applying summarize and I want the mean of displacement. So we can use group by and summarize together. So the output is cylinder is, we have these three types of cylinder, 4, 6 and 8, and applied mean on displacement. So mean of the displacement is for 4 cylinders it is 105, for 6 cylinders it's 183, and the car which has 8 cylinders, the mean of the displacement is 353. So this is how we can apply a group by and summarize together, and we can do all the arithmetic calculations using the Dplyr functions. So that's all for today's session. Hope you find it interesting. In the next session we will see how to use ggplot libraries and plot some graphs. So stick around guys, we'll see you in the next session. If you like my training session, please subscribe to my channel and don't forget to press the bell icon to get the notifications of my new sessions. This will support and motivate my channel. Thank you.